The next test is the two-way Anova with replication. So far we discussed about without replication. Now with replication, how we are going to do it. So for that, we are going to take another case study. And this is the data set given to you. And this is the data set. You have it in your hand. The price, the columns are nothing but your price. Low price, medium price, high price. And the rows are like your advertisement, which you are spending money in advertisement. If I spend more money on advertisement and if the price is more, will that help me to increase my sales? What the common sense says? Let's say if I spend hell lot of money in the advertisement, but the cost of the laptop is very high. You think you can afford to buy? No, right? Let's say the advertisement, I'm spending a lot of money, but the price is less, but the sales is more. Okay, you want to understand this one. So in this case, we want to understand or we want to investigate the combined effect of these two factors, price and advertisement on the product sales. Okay, in this case, I have used the two-way Anova with replication. Why it is called replication? Look here, in each group, low, medium, high. In the advertisement, low advertisement, I've taken more than one row data here. Unlike the without replication. Okay, for each row you have only one record, but whereas in this one, for each group, you have more than one row is there. Here also for each group, you have more than one row is there. Right? And how did you get this one? This is your entire group's average, the first group average. And this one is, if you click on it here, it will get highlighted. So that means the second group's average. This is your third group's average. Okay. And this is your overall average. Obviously, you need to find the overall average. One second. This is all the values put together. So excluding the effect. Okay, guys, this effect, in this case, we need to find out the effect here itself. In the case of two-way ANOVA with replication. Okay, you might be asking this question, do I need to use Excel to do the test? Excel is far better because it gives you a lot of statistics compared to other tests. Okay, fine. Now, here I click on the data tab, click on the data analysis. Two-factor with replication. I'm going to select it. I'm going to click on OK. And in this case, I just select all the numeric values, not the effects. The effect we calculated. This is the original data. Okay. I'm going to select this one, new worksheet, and I'm going to hit OK. Is required. Okay. Here, I think I did not select. Okay. Rows per sample is 3. Okay. Rows per sample is 3. I think it requires, yes, it requires the text column also. Okay. I select this is what is happening. Okay. So how did I do this? I'll show you one more time. Go to the data tab, click on the data analysis, two-factor, click on OK. And you need to select all the values, including the text. In this case, the previous case, text, you are not supposed to select it. But in the with replication, you have to select the text also. Rows per sample, you can say, look, here we have 3, right? That is what I mentioned it here. Once you click on OK, it will generate something like this. Okay, here the same thing, it got generated. I copy pasted it, and then in the background I gave the color, and then I just aligned it correctly. Then if you see here, the low, medium, high, the columns, right? You can see it, and some average will count some. Look here we have in the low we have 3 is there, medium we have 3, and high we have 3 values are there, and total we have 9 values are there. Some 94. In this case, 94, right? So 94, how did we get this? This one, 44, 64, 74, 84, 88, 92, 90. Yeah, this one. One second, I'll just select this one. Okay, this one gives me 79, and this one gives me 94. Yeah, the column. Okay. So here the column level statistics it gives us. Okay, column level statistics. Similarly, medium, high. That's all. Okay. And our job is very simple. You scroll down We have something called Anova table. Look at the p-value. But when you compare the previous test and this test, right, you will find an additional value here, the interaction. That's all. So what is sample? Sample is nothing but your rows. Okay, rows, the advertisement, all the things, and then the columns are nothing but your low price, medium price, high price. Okay, so here it just gives you the sample. Sample is nothing but your rows, advertisement. The columns are nothing but your price. So does advertisement has any influence on the sales? Yes. Look here, in this case, the reject null hypothesis, because p-value is less than alpha. Alpha is 0.05. You just keep that in mind, okay, all the time, okay? And the columns, 2.2 E minus 0.5. I told you E minus 0.5 is, you need to prefix with 4 zeros. Obviously, this value is much, much lesser than that one. Hence, the second columns are nothing but prices. Columns are nothing but price. The price, the p-value is much lesser than this one. Because here we see that E minus 0.5, which is nothing but you need to put 4 zeros before that. 0.0000022, that's all. This value, since this p-value is much lesser than this one, we can conclude that the p-value is statistically highly significant when it comes to the price columns. Hence, we are going to conclude the price has an influence on the sales. Next one is the advertisement is also, sorry, the columns are, columns are price and advertisement is this one. Yes, advertisement also has an influence on the sales. Look here, in this case, we need to conduct 3 null hypotheses. The first null hypothesis is advertisement has no influence on the sales. Here we are rejecting it. And then we are going to conclude advertisement does have an influence on the sales, but the sales, sorry, in the case of price, when it comes to price, price is the p-value for the price is statistically significant. Hence, price plays an important role in terms of our sales performance. There's a common sense. When you sell the cheaper the price, more the sales can happen. And then one more null test when it comes to this with replication, 3 hypotheses needs to be conducted. The third one is interaction. With the combination of these two, can we see any influence on the sales? Does advertisement and price combination, with the interaction of these two, can we see any influence on the sales? No, because the p-value is greater. In this case, the p-value is greater than alpha. Hence, you fail to reject the null hypothesis. You are going to conclude that the combination of price and advertisement does not have any influence on the sales. You fail to reject the null hypothesis. Okay, here. But in the previous cases, since the p-value is much, much lesser than your 0.05 alpha value, we are rejecting the null hypothesis. That's all. It's very simple. So in this case also, we compared the two factors. The one factor is price, other factor is advertisement. Of these two factors, which one drives more sales? Obviously, price. Both factors are important in terms of driving the sales. That's what we have seen it. But the compared to advertisement, the price plays an important role in driving the sales. Okay. But the combination of these two does not have any influence. What do you mean by interaction? For example, I'm spending a moderate amount in advertisement, but the price is moderate. Okay, with the combination of these two things, you will we are not able to conclude with this p-value that we cannot reject, we can reject the null hypothesis, right? We cannot reject the null hypothesis with this. We fail to reject the null hypothesis since we conclude that the interaction of both the advertisement price have no influence on the sales. So that's it, guys. This is what your two-way ANOVA with replication. Why? Because the replication for each each factor. Look here. In the case of see, in this case we have only two factors: advertisement and price. Each factor has 3 levels in it. Even in this case, it has 3 levels in it. Okay, so these are 2-factor ANOVA with the replication. These each factor have more than 1 rows and columns. Okay, fine.